Recording in progress.
Okay, I hope you can see me. Oh, you can see the
Yes,
slide.
yes, it can be you now.
Okay, perfect. Um, okay, so let's start the fourth session, which is on how you orchestrate um, your application. So if you look at simply the title of the topic of this session is secure orchestration using Kubernetes. So more or less like the most difficult part to understand over here is what is this orchestration? Uh, okay, let's go back and let's recall the Docker part. So the second session, we discussed that how um, we can containerize an application. So the moment you containerize an application, you can basically, literally, you can start thousands number of the containers from the same image, and that will not take even much time. But if you look at the bigger picture, a bigger software, like you have large number of modules are there, you have hundreds of different microservices are there. So when you have one microservice, it may run inside one container. So when you have a bigger picture, you have a larger number of containers are there. How would you manage those containers? Because what we discussed before is that um, you have the Docker command, which will allow you to create, start, then your run the container, your stop the container, If there is any problem, just stop and remove the containers. But what will happen if you have thousands number of different containers out there? Sometimes even it may go bigger than that. So in that case, manage, when I say manage, it means like you manage their state, you manage, monitor their health, you manage the life cycle of each and every containers, you manage the communication between those containers, you manage how a container can be discovered, you manage how you can observe each and every containers, you manage if there is any sensitive data already compromised or not, the sensitivitiness of the data, or you manage the scaling of the data, sorry, your scaling of the entire infrastructure. You manage if something fall or if something failed in between, then how to restart again, or you how you can provide higher degree of fault tolerance. So when you have a lot of all these different aspects, at the time, Docker only is not enough. Definitely, you may say, then how about the other software solutions or other solutions? For example, Podman, for example, Containerd. Usually, those solutions also doesn't provide this kind of facilities to manage larger number of containers. Those are very, very efficient when you manage single container. So, uh, so obviously, those solutions, they do provide a different solution for the larger for management of the larger number of containers. For example, Docker. It also provide a different tools called Docker Swarm. So the Docker Swarm will basically allow you to manage multiple number of containers, uh, allow you to manage your application where you have large number of containers communicating with each other. And in addition to Docker Swarm, obviously there is another solution which is very popular, and that is what your Kubernetes is all about. So, but our discussion was that how to orchestrate the containers. So container orchestration solution will basically tell you the orchestration means that you you manage the life cycle of each and every container. You manage the implementation of each and every. Give me a second. Let me just back out. Sorry for the noise. Uh, so orchestration, it means you also not only manage the life cycle of each and every container, but also you manage which container should start after which other container. So you orchestrate the entire workflow, and the whole workflow is consisting of large number of different containers. So further, your Kubernetes is one of the very, it is becoming a de facto uh, when it comes to the orchestration of the containers. Okay. Um, yeah, so orchestration basically refers to the control, logic, and the communication between those containers. So if you look at the Kubernetes, it's also known as Kubernetes. It is also a open source project. It's actually started from the initial solution called Borg, Google Borg, and from there the Kubernetes is developed. So some other alternate solutions like you have, if you go to Amazon, then you have this Amazon Elastic Container Service. For Azure, you have this Azure Container Instances. Again, all of them are having their own set of features, own ways to implement the management or the orchestration of the containers. If it is Amazon Elastic Container Service, then again, since it is within the ecosystem of Amazon, then obviously it will work much better. But you cannot simply download the Amazon Elastic Container Service on your on-premises system, and you can manage your containers. That is something probably it's not possible with such kind of proprietary solution. Some of the features, as we are discussing before, that how you scale the application horizontally as well as vertically. In most of the cases, it is the horizontal scaling. So horizontal scaling is all about you create the multiple instances of the same application model. So if it is the front end, then you create multiple instances of the front end. If it is the back end, so if it is the API gateway, you manage the multiple instances or create the multiple instances. If it is about uh, video streaming platform, basically you scale up, you scale horizontally when the number of customers will increase. Self-healing is all about like if any one of the container due to some reason it crashes, then automatically your orchestration solution should be able to detect it, and then accordingly it will create a new instance of the same container or of the same model. So that is what your self-healing is all about. So if you look at the components of the Kubernetes, the overall uh, structure or the architecture is that you have the master. It's basically following the master-slave model, where you have in the master you have controller. You have okay. Let me on the master you have oh sorry you have cluster. So basically this is kind of a cluster store. Your controller, which will control all the different worker node. Um, your cluster store is basically your storage of the metadata. Your scheduler is there. Your API server is there, through which you provide all the instructions. And uh, within the Kubernetes system, the components can also interact with each other through this API server. And within each node, you'll see over here pods, and different pods are there. So we'll discuss what is pod and whether it has any kind of meaning or any relationship with the containers or not. So these are like the master and worker node. So if you go deeper into the master node, in the master node, as you saw before, you have the API gateway. So the API gateway is kind of is the entry point, or it is kind of a bridge. Like you can communicate with different components through this API gateway. So, for example, if from the user interface, if you are deploying some application, then basically all the requests will go through the API gateway. Or if you send any kind of request from the command line or any command from the terminal, that will also go through this API. And the API server will basically route the request to the right component. You'll also have a scheduler in the master node. So the scheduler is basically, for example, if you are creating or if you're deploying some application, at that time, which model will be deployed on which node? Because again, it's a cluster. So it's not only one PC or one server is there, and on top of that, you are then deploying your application, but it's a distributed fashion, where like you have multiple servers out there, and on top of that, you are installing your application. So that means sometimes it may happen that you may prefer the front end to be deployed on the server one, and the backend to be deployed on the server two, API gateway to be deployed on server 3, 4, 5. So you may have different kind of strategy or the logic, which one should be deployed on what. It's sometimes also possible that some module, you don't have any restriction where to deploy it. But in that case, your scheduler will basically decide where this specific component or the module of your application should be deployed in which virtual machine or on which worker node. So at that time, your scheduler will basically make sure that um, the application model is deployed on the right worker node. And there is another the etcd. Etcd is basically is kind of a key value based distributed consistent database where like you have all the meta informations will be stored over here, including when the application crashes, how much time it took to to create a new instance, uh, including the user's information, including the list of requests received by the API gateway, including the health of each and every node. I mean the health of entire cluster, not only the nodes, uh, and everything about your infrastructure will be stored in this etcd. And this is basically a distributed fashion. So uh, now when it comes to the worker node, the worker node basically will have two major components. One is kubelet and the other one is kubeproxy. And within that, uh, definitely in the worker node, some sort of Docker or related solutions should be deployed or should be installed in the worker node to manage the containers. So so in the worker node, you'll have the kubelet, which will basically get the configuration of pods. So for the time being, pod you can think of it's a container. It's not exactly a container, but for the time being, for the sake of easy understanding, you can think pod is just a container. So kubelet will basically receive the configuration, how the container should be deployed, should be created, what should be the configurations, everything. And then kubelet will basically interact with Docker. If not Docker, then if Podman is installed, then it will interact with Podman. If any other solution is installed on that worker node, then kubelet will basically interact with that to create the containers. So imagine that kubelet will basically send the information that what container should be created and what should be its configuration. It will simply send that information to the Docker, and then Docker will use that information and create the containers. But kubeproxy is something which usually works as a load balancer or a proxy, uh, so that whenever you will have, because it will manage the interaction coming from outside the cluster, it will manage the interactions or the communications coming from within the cluster. So it is possible that one service or one container might be interacting with another container. So in more general term, we can say one service might communicate with another service within your application, and both of the service may be in a different nodes, different worker nodes. So in that case, when one service will send some message to the other service, it needs to go through this kubeproxy. So, and pod is basically, um, you can say it's a combination of one or more number of containers. Logically, usually they do run together on one node. Now let's try to understand what is a pod. Yeah, so let's try to understand what is a pod. So pod is nothing but you can think of inside a worker node. Uh, Sometimes what you do, you have the volumes and you have the application. So like yesterday, what we were saying that we have the volume where like we keep all the changes, uh, all the files, data, everything we keep inside the volume, so that even if the container is removed, still we'll have the data safe, right? So when you have uh, some related containers along with their volumes, when you group them, you can keep them in the inside a pod. And pod will have its own IP address. Pod will have its own IP address. And what will happen is that whenever you create a pod, At that time, um, all the related containers, all the related volumes will be created. When we remove a pod at the time, whatever inside the pod, everything will be removed. And when we scale, when we say horizontal scaling, at the time, the instances of the same pod will be created. The replication will be there. And definitely, a pod cannot be distributed among the different worker nodes. So whatever the containers, the volumes there inside a pod, that will be within one worker node. So two pods of the same deployment also usually run on different worker nodes. Okay. Now, so this is one example of how you provide the specification of a pod. So over here, the technical term, how you refer some in general, and the pod, the deployment, everything is, these are all some sort of like resource. So pod is kind of, the resource type is the pod over here. So in Kubernetes, the pod, if you look at the specification, this is usually again written in YAML format. You can say what is the version of the pod, then what is the kind, and kind is basically your pod. And then your metadata, that means what's the name of that pod, what's the level. So levels, this is something is used to select a very specific pod uh, for the communication or for other kind of operations. Now inside the pod, you'll have you can have multiple containers. So for example, over here inside the specification spec, you can see it's the containers, it's the plural. So obviously there is a possibility that you can mention multiple number of containers. So one of them is you provide what's the name of the container and then what is the image. So this is what your Docker um, image name along with the tag. And then port. So this is what, when you run the Nginx, then through which port number you want to access it. So that is something your container port is there. And then if you want to know what the different ports that are created inside the cluster, Kubernetes cluster, you can just use the command kubectl. It's Kubernetes control, kubectl get ports. This will basically list all the ports in the namespace. So over here again, namespace uh, it's kind of a logical grouping of resources. Sometimes it may happen that the namespace could be system, it could be the visualization, it could be the monitoring namespace, it could be the front end namespace, it could be the backend, it could be API. So these are just some sort of like um, logical grouping of different microservices or different services. Again, if you want to know more about the ports, then you can use the flag -o and wide. This will basically list all the ports in the current namespace with more detailed information. So this is what, if you describe, if there are some ports. So before, when you say get ports, basically it will simply list the list of ports. So for example, the output could be, it may look like what is the name of the port, and then whether it is ready or not, and then what is the status, currently it is running, restart 0, and what is the age. So if you look at the ready, so this column is saying that how many ports should be created, should be ready, and so far how many are ready. So one by one, that means that there was a requirement of requirement of 1, and 1 is ready. Restarts, it's saying that how many times it restart because of some sort of like, let us say, some failure. So it also tell you like what is the number of time it restarts. Age is basically the how old that pod is. But if you still want to know more about a specific pod or all the pods, then you can use the describe command. So the describe command, um, along with the keyword pods will tell you what the list of pods, for example, over your name, your namespace, then your node, on which node it is there, and then what is the level, and few other like what is the IP address of that pod. After that, few other things like your port number, your image, and then probably few other things like your environment, your mount, and few other informations you'll find. So if a pod is not running due to some reason, then the best way to investigate is to look at the describe or use the describe command and look at the pod's information, detailed information. Now, again, when we say pods, it, you can have multiple pods in a single node. So the Kubernetes itself is all about like a cluster, right? You need to have multiple number of worker nodes. You can have, sometimes it may have like hundreds of different worker nodes, and also multiple master nodes you may have for the high availability. So uh, the node is basically, it's just a virtual machine. It could be a physical machine, it could be a laptop, it could be your PC. So you may also like form a group, and you can take, or you can use your laptops and to form one single cluster. So within the node, you may have multiple pods, and where like each and every pod will have their own IP address. And these IP address obviously will be assigned by your, will be managed by your kube proxy. So again, inside the cluster, so when you have multiple number of nodes, you'll have one cluster, and within the cluster, definitely you'll have one controller. So when you, if you want to know the information about the cluster, you can just provide kubectl and cluster info. You may need sudo privilege, or sometimes it is not required. It depends on how you have installed kubectl. So now over here, if you look at what is the control plane, what is the IP address and the port number 6443, your DNS for the internal communication, your metrics server somewhere for about the Kubernetes, and other everything you can see. You can also export that one in a JSON format. Now, so when you have the Kubernetes cluster having multiple nodes, obviously in this demo, you'll not be able to see multiple nodes, but we'll have some minimal version of Kubernetes implementation. We'll see that one in the demonstration. So let us say in the Kubernetes, you want to deploy something. So there are a few terms that you need to be familiar with. One is app, the deployment, the service. So when it comes to the application, it's just your application which is expected to be containerized. So remember over here, this is the minimal requirement, that if the application is not containerized, then definitely that one you cannot simply deploy using Kubernetes cluster on top of this Kubernetes cluster. So deployment, it's again, if you look at here, give me a second. Yeah, for the deployment, the resource file may look like this. So this is called the resource file, the deployment resource file. So here again, the API version kind is deployment. So this is the type of the resource. Then your metadata, where you have levels app equal app is nginx. Then here you are saying the replicas is 3. That means you can imagine like 3 replicas of nginx will be deployed. Your containers specification. That means your deployment is nothing but it's a logical entity where you may have multiple pods grouped together. So if you want to know the list of deployments, then it's basically a kubectl get deployments is enough to know the number of deployments you have. So when you scale something at the time, or when you deploy a deployment at the time, all the pods within the deployment will be removed. So in this deployment, there is only one pod. Sorry, within this end deployment, there will be three pods, three replicas basically. And within each pod, you will have one container, nginx container, right? So these deployments, they're also needed for rolling updates, rolling back, auto scaling, and manage the replica set. Now coming to the services, services is again is a different layer of abstraction, which will allow you to define the policy, how to access the deployment or how to access your application. If you want your application to be publicly available, for that you need to go for the services. Now we'll discuss more about the services later on, but let's try to again summarize what we discussed so far. Now let us say if you want to write a program, let us say it's a simply a Flask application, or like you have 404.html file. You containerize that one that we discussed in the previous sessions. You build the Docker containers, or basically container image, and then you post that one to your Docker Hub or GitLab registry, right? So this is what we have also discussed in the previous sessions. So using this image, you create a pod, and let us say it's a pod A. Now pod A will be used along with the number of replicas, and you create a kind of a abstract entity called deployment. So when you create a deployment at the time, you basically your Kubernetes will create the pods. So when we say create the pod, it means it will basically download the Docker image and then it will run the container. So when you create the deployment at the time, it will also look at what's the number of replicas. So if you have 3, that means your Kubernetes will try to create 3 replicas of the same pod. So now question arises that what will happen if the number of nodes inside the cluster is less than the number of replicas? At the time, obviously, it cannot satisfy that condition, right? So if the replica set is 3, that means your Kubernetes require 3 number of different nodes. Okay. Now, once you have the deployment, after that, you create a service to expose that deployment or that application to outside. So without this service, you cannot simply access that application. So at the end, the initial 404.html file will be containerized and will be deployed with the replica set of 3. That means will be deployed on 3 different nodes, and it will be accessed outside the Kubernetes cluster through a service, required service, through a suitable service. Now question arises that how all these things will be, what is the whole workflow? So what happens if when you want to create a pod? So this is the very basic things. Obviously, we'll not go beyond this one because it will be much more complicated. So I want to emphasize more on the basics, that what actually happen, how different components will be involved when you create a pod. Obviously, after that, it will be easy for you to understand what is the workflow when you create a deployment, what is the workflow when you create a service. So those things will be a little bit easy to understand if you don't, if you know very clearly what is the workflow of a pod creation. So let's see, in the whole cluster, you have one master node and you have 2 worker node. And in both the worker nodes, you have kubeproxy and kubelet. And in the master node, you have scheduler, you have etcd, you have kube API server. So user is connected to the API server as usual. So what will happen if, so what will happen when user send any request to the API server. So first, user send the request to the API server to create a pod. Obviously, that means user also provided the specification. And then your API server will simply send, write that data to that pod to etcd. So Kube API server will simply tell etcd that user has provided this specification to create a pod. Please write it down in the etcd. Now, once after doing that, it will also send the user some sort of like notification saying that the pod is created. But actually the pod is not yet created. It's noted down in the etcd. Now the third is that scheduler will always interact with the Kube API server. And very frequently, scheduler will always make a request to the API server that is there something to be created. Now your Kube API server will inform that yes, there is something to be created, and scheduler will now get the instruction that one pod needs to be created, and for that your scheduler will find the available nodes. So scheduler will again, obviously during that time, scheduler will interact with the etcd to inquiry how many number of nodes are there and what are their health. Now scheduler, what it will do, it will take the input, what is the pod, and then it will take also the input information, about the detailed information, health information about all the worker nodes. And based on that, scheduler will decide which worker node to be selected to deploy the pod onto that worker node. So basically your scheduler will find the best worker node, and let us say it found worker node 2 instead of worker node 1. And definitely when we say find the best worker node, at the time it needs to look into the health of the node. It will look into the resource availability of the node and the condition also. Because sometimes you may say in the pod that do not create this pod in worker node 1 or worker node 3 or worker node 4. And so those conditions also needs to be taken into account to find the best worker node. And once scheduler find the best worker node, after that scheduler will inform the API server that pod now should be created in worker node 2. Because before, when Kube API server written that create the pod, at the time API server didn't know that on which worker node to be created. So now scheduler informed the API server that please update the information saying that the pod should be created in worker node 2. Let us say worker node 2 is the best, is the suitable one. After that, your Kube API server will write that information to the etcd and update the desired state of the whole system cluster, the whole system in the etcd. Now after that, Kube API server will send the information to the kubelet. So your kubelet, obviously since it is Kube worker node 2, so API server will send the request or the command to the worker node 2, especially your kubelet. So kubelet will get instruction that now it's time to create a pod. So now it will interact with the container runtime. So container runtime, it could be Docker, it could be podman, it could be container D, it could be something else. Okay, so if the Docker is installed, then your kubelet will communicate with Docker to create the pod in worker node 2. In most of the cases nowadays, Docker is not required because in the current operating systems, always you'll find container D is the runtime engine instead of Docker. So your kubelet may always interact with container D to create and manage the lifecycle of each and every containers. Now overall, so over here now you know that from the very beginning when you just send the kubectl command to create the pod and how the pod is created in worker node 2. Now overall, your control manager will basically regulate the entire cluster, tells the node what to run, how to expose the application, how to commit the changes, and so on. The control manager will also will be watching the desired state. So desired state means when you send the instruction to the kubectl command, and when you say that create a pod, that means in the whole system, the desired state is there should be also a pod in the whole cluster. So that is your desired state. So the current state, there is no pod, right? So this is basically the job of your control manager to see what is the current system and what is the desired system. This is how actually your Kubernetes actually work. So when it comes to the services, we'll quickly go through this one. When it comes to the services, it's basically a service in Kubernetes is an abstraction which defines a logical set of pods and policy by which to access those pods. So it's basically, in short, it will allow you to expose your application over a network. Now, how to expose that one? Sometimes some of the services are should not be exposed to the public. At the same time, some of the services should be exposed to be communicated of by other services. So the service to service communication should be there sometimes. So for example, your database service. At the time, it should not be allowed to access the database directly. Rather, the services deployed on Kubernetes should be allowed to access the database. So that is what the difference, and that's where your services will come into the picture. The services will also help you to manage the load balancing, to implement the load balancing. So for example, if you have different replicas, at the time you can expose your application to a load balancer service, and the service will basically provide you an IP address, a static IP address, and the moment you send any request, the request will be forwarded to the right worker node. So give me a second. So in the Kubernetes, one of the service type is cluster IP. So in cluster IP, usually what happens, if you look at this picture, let us say this is the VM A and this is VM B. So in VM A, let us say there is one pod, and in the pod, you may have a container, right? And inside the container, let us say your Flask application is running, and your Flask application is listening to the port number 5000. But that is inside the containers. So if someone wants to access that Flask application from outside the container, then again, from outside the container, you need to have some port, right? Okay. So within the port, again, port will have some IP address. The pod will have some IP address. And when you create the container at the time, you can map the port number of the port or the pod with the port number of the containers, right? So whenever you send any request to the cluster IP, so what will happen is that inside the cluster IP, you will get some, from the cluster IP, you will get some IP address. Let us say 10.150.1.12 and some port number that is 3000. So this one will go to the required pod, and when it goes to a pod at the time, it will again 3000 will be mapped to this 5000, and then it will redirect the request to the right container. So this is your port number. This is usually called the target port. But using this cluster IP, some user from outside cannot access this cluster IP. So you need to send the request from within the Kubernetes cluster. Now what will happen is that when it comes to the node port, This is again a different type of service where you can directly access the service by using the IP address of that VM. So if you have two number of VMs, each will have its own IP, then you can directly send the request to that IP, and definitely during that time, your queue proxy will be basically responsible for serving this request. So when you access as a user, when you send the request to access that service, you use the IP address and then you use the port number. So when you send the request, your virtual machine, it will also now forward that one to the node port and the IP address of that port. And over here, it will map to the port number of the container. So here the question arises that you use the IP address and it may change over time. So your load balancer is another one, which will allow you to access the service using a very specific port number. And then over here, the request, it may forward to the VMA or VMB. It depends on the server. It depends on the load balancer. Okay, let me see. There's some chart. Okay. Okay. So this is how your load balancer service will run. And obviously, if you look at the YML file, the resource file, for example, in the node port, if you look at the resource file, you'll see that somewhere your metadata specification selector type, yeah, type. So this is where your because it is the node port, so you just need to provide the type is equal to node port, and then you provide the port number. So the port number and the target port, let us say it is 5000. So 5000 is the target port. Node port is 30010. So this is what the port number of that virtual machine. And then port 8080 is basically the node port port number. So you can use, so through this also you can access this service. Now, if you look at the advantages over here, again, it's organization, easy organization of the services or the ports. There is a huge community working on these Kubernetes. And also, since it is like open source, you can deploy it anywhere, any cloud. So this will basically mitigate the vendor lock-in issue. So once your application is ready to be deployed on Kubernetes environment, now you can deploy the same application in AWS, in Azure, in Google, and also in some other cloud platform, irrespective of what is the platform. If the platform is supporting Kubernetes, that's enough. Now, but the challenges is that it needs a lot of time for you to first get familiar with the Kubernetes. This is the one of the biggest challenge. The learning curve is really very big. So again, since it is a distributed system, um, obviously the complexity will be inherited. So the whatever the challenges or the complexity with the distributed system, everything will also be it will also be there with this Kubernetes. And so, for example, like if you are not able to access any application, now you have no idea why you are not able to access the application. Is it because the communication is broken? Is it because the port number are not properly configured? Or is it because there is some problem with the pod? Or is it because there is some problem with the deployment or the pod or the container itself? So there are a lot of different layers out there to debug why the application you are not able to access that one, right? So this multi-layer implementation makes it very difficult and makes the whole problem a very complex one. Logging is again a different challenge. For example, like if you want to log each and every activities, then you need to look at, or you need to log the containers activities, you need to log the pods activities, the deployment activities, the nodes activities, the each and every components activities. So it's really again very difficult task, very tedious task to manage the logging of your application once you deploy. Uh, so, so that's all about the theoretical aspect of Kubernetes. Let's quickly look at the demonstration. Okay, I'll try because I know the complexity of Kubernetes, so I'll try to finish it early, little bit early. I'll not try to cover everything, each and every in depth. Uh, so I want you to first understand, and then if you have any question, then you can ask. Uh, let me share the screen. I hope you can see my screen. Uh, okay, so what we'll do over here is, at first, Kubernetes again, as we saw before, that it's a cluster. So, uh, but most of the time we don't have a cluster, rather we have a single machine. So at the time we need to, um, yeah, at the time probably we need to create a cluster, a minimal version of Kubernetes uh, we can use, and that is what we call Minikube. Uh, so Minikube, it will allow you to learn Kubernetes. And just give me a second. There are some urgent call is coming. Yeah, sorry. Uh, okay, so let's have a quick look over the minikube. So what is happening over here is that uh, will not actually install or will not actually use Kubernetes or K8s. Rather, we will use minikube. So I have already installed minikube because sometimes it takes a bit longer time to install minikube. So what I did, I have already installed and started this minikube. To install this one, it's very simply you download minikube installer and you keep it somewhere. And then after that, once you install this minikube, uh, you use the command minikube start. And node 3 is means like I want the cluster to have 3 different nodes. So node, you can think of it's a worker node. Okay. Uh, Give me a second. Okay. So node is equal to 3. It means like 3 different worker nodes will be there. Come on. I'm getting this call, delivery call is there. Okay. So what I was saying that we have, sorry, I have already started this minikube. So here you can see there are like 3 different nodes, and it's a demonstration with multi-node. So if I look at, if I want to see kubectl get nodes, then you will see that like 3 different nodes are there. Let me increase zoom. Yeah. So kubectl get nodes. So kubectl is always the command. So basically what happens is that whenever you send any request, this instruction or this command will go to the API server, and then from there, it will query the list of different nodes, and then API server will send this information to back to you. So here, get nodes, it will give you 3 different nodes, the name of each and every node, their status, whether it is ready or not, and their roles. So control plane this is, and these two are worker nodes. When it started and what's the version. So the age is also matters. Now, if I want to know what are the different pods, that is something we discussed before. Get pods. So here you can see some pods are there, and this is currently this is there should be one ready, but the only zero, sorry, one is not ready, so 0 out of 1 ready because there is some error is there, and it restarted 44 times. So you can think of how many times it is like restarting. Another another pod, BGBox2, 1 out of 1 is ready. So all of them are ready and it is running properly. And it restarted only 1 time. So this is what your pod is. Now, if you want to know more about the pods, so what you can do, let's go and then wide. So if you do this one, okay, let me try to, yeah. you do this one, then over here you will be able to see which pod is deployed on which node. So for example, over here, this one is deployed on multi-node demo on this node, and the BusyBox 2 is deployed on this node. Okay. Also, their IP address of each and every pod. Now let us say try to look at what is the kubectl describe pods. So in this case, we have two different pods, right? So all the ports, the detailed information will be provided over here. So for example, yeah, it's BusyBox 2. Let's look at BusyBox 1. So this is the first port, BusyBox, which is the node demo, the second node it's deployed, and then you can see what is the image. After that, you can see what is the state. It's waiting, and why it is waiting. The reason is something called crash loop back off. And some message, detailed message, you can see failed to create the task for containers, failed to create same task. It's something called OCA runtime create failed, run failed, unable to start the container process, error during container initialization, execution of C program files git user bin sh. So bin sh, no such file or directory is present, and that's the reason why it is failing. You can also look at all the events. So if you want to always keep in mind, if you want to debug any bug, any pod, if it is working or not, and why it is not working, in that case, you always need to look at the events. And most of the cases, the event will help you to identify or to locate the error. And for example, BusyBox 2, if you look at everything is running perfect. If you look at the events, yes, pulling the image BusyBox, and then yeah, and then pod sandbox changed, and then the container is created, it started, and then successfully pull the image BusyBox. So all the events you can see over here. So it's about the pods. Now let's look at the kubectl get deployments. So here you can see no resources found in the default namespace. So what you can do is probably it is a namespace all. I guess it is. Yeah, I guess it's all. So if you are confused what to do, you can use help. So help will basically give you the manual of that command. So for example, over here, what we can do, we can look at n, what is that? Board wide API resources. Okay, somewhere the n flag is there. Okay, anyway, leave it. So, so this is the get deployments, and again over here also you can use the same flag wide since there is no deployment, so that's why like it's not giving anything. The other one is so when you let deployment pod, and the other one is service. kubectl get services. So here you can see there is only one service, Kubernetes service, and the type is cluster IP with the IP called 10.90.96.0.1, and the port number is 443. So this is only one service is there. Let us say, okay. guess it's A. Okay, there is some flag is there, which will allow you to query all the services, all the ports in all the different, all namespaces. But anyway, uh, now here question arises that uh, how you can deploy something, how to create a pod, right? Uh, for that, what you can do is, okay. So when you need to work with the pod, what you can do is, let us say we want to create a pod. Okay, so this is the BusyBox pod. Uh, we can for service deployment pod busy. Yeah. So this is one. This is the resource file. Okay. Let me look at the. So this is the resource file. So if I want to create a pod, first the API version, the kind is pod, metadata, some name I have provided, and then some containers. So this one I can say instead of BusyBox, I can say let us say Nginx, and image is Nginx. Oops, sorry. Yeah, Nginx latest. And then command, I don't want to give any command. It's not required. And then restore policy is always now. I can say some port number. And for that, you can use the port number. Okay, just a minute. Yeah. Let us say we'll give ports and the container port. So what I want to know, let's say over here 82, and then now this is usually called the resource file. So the resource file is something which will keep track of, where you can provide the detailed information how to create some resource. Resource, it could be pod, it could be deployment, it could be service, it could be replica set. So once you have everything in the file, what you can do is you can simply, okay, let me first go inside that. For cd miniq and cd deploy. Now, what you can do is kubectl apply dash f, and then you have something called the file name. So dash f is basically your file name where your specifications are mentioned. So the file name is, let's say, pod underscore busybox.yml. Now, if you hit enter, then here you will see that some problem is there and for which it was not able to create it. And the problem is that the pod name is same. Somewhere 29 identical field. So that means something is, it should not be BusyBox, it should be Nginx, let us say. Right. Now let's try to execute again. So here you will see that pod Nginx is created. Now if you look at the list of pods, kubectl get pods, then you'll say Nginx pod is container is creating. So still is creating. And if you look at describe, DSCRIBE, describe pods, then here you will see successfully assigned pod to the to this node. So it has successfully pulled the image and then assigned that one to the to this node. And so this is the pulling and this is the schedule. So basically, this event is performed by the scheduler component, and this event is performed by your Docker or your what is that called, runtime engine component. Let's see, there are some sort of. So now here, let us see again what is the status of the pods. So here you can see the node port, Nginx port is currently running and without anything. So the replica is 1.1. So well, there is only one replica set and one is ready. So this is one kind of a pod that you have created. Now, if you want to create a deployment, let us say, so I have already created one resource file for the deployment. So in this deployment, what I have is, again, this is the resource file of this deployment. So the API version is there, kind is deployment, name is first deployment. You can give any, let us say, first underscore Nginx deployment. Oh, sorry, this typo. Nginx deployment label app Nginx, and then replica here is one, selector is this one, and then you have something. So basically this is the specification of the container. So the container port is 80. Let us give this one 8080. Now again, for this deployment, what you can do is kubectl, sorry, why? Now kubectl, sorry, apply, that's F, and then your first deployment.yml. Now, if you click on this one, then here it is saying that the deployment is invalid. This is because if you look at the name, the invalid value first underscore nginx underscore deployment. So this is because you have it should not be having any underscore. So I updated and then let's apply. So deployment app is created. Now, if you look at again kubectl get deployment, then you'll see this is one deployment and the ready is there, up to date available is 0, sorry, 1. Here you can see that the replica is 1, right? Now let's see what are the different pods. Sorry. And if you look at the pods, then you'll see that there is one new pod and the first word is the deployment name and then some alphanumeric characters or some characters. So this is your pod name. And if you look at the wider version, then you'll see this pod is running, having some IP address, and it is installed or it is deployed on M03 node. Now, what will happen if I increase the replica to 2? So if I increase the replica to 2, that means I should have 2 different pods. And let us see if it is there. But before that, I need to apply. So here you can see it is configured. It's not created, rather it is configured. Now again, look at the list of ports, and here you'll see there are like 2 ports. One is currently creating, and the first port was created in M03 node, and the second port is created in M02. So again, let's see. Yeah, content creating. So it's just taking some time to create in that node. And since it is not yet created and the IP address is not yet available, let's quickly see again. Okay, it's creating. So here you can see that only in this resource file you change. Let us say let us say your name of the containers, or let us say your what's this called? Your any other specification, and you just apply using kubectl apply command, and that will be basically applied to that deployment file. So over here, let us see again if there is, okay. So both the ports are running, and one port is running in M03 and the other one is running in M02. Let us say what will happen. We have a total of three nodes, but what will happen if we say replicas is equal to 5? Now let us see if we are getting any error, or let us see that. Okay, my system is getting hanged. Okay, apply /f, sorry, first deploy. So again, this is configured. kubectl and get ports /o wide. Oh, okay. Okay, so here you can see that like it is creating a total of 5, and right now it's not giving any error. Since since you want the replicas of 5, so definitely if you have lesser number of nodes available at the time, this will create 2 replicas in one node. And same thing happen over here. This on 03 node, you have like 2 replicas. On 02 node, you have another 2 replicas, and over here it's probably creating somewhere. So it is creating on the first node. So if you look at the list of nodes, so here you will see the like 3 nodes, and the 5 replicas are now being created on 3 nodes. Now you can again select one, replicas is equal to 1, and then you can say apply f first deployment.yml. Now it is again configured. Now if we again look at kubectl get ports/o. So now here you can see again one node, so one replica is there. So obviously here it is one. That doesn't mean that all the Docker containers are already created. It's somewhere in behind the scene. It is being all the containers are removed. Instead of that, it's simply just saying you that it's removed, but behind the scene it may take few seconds to remove all the replicas. So this is how like you can increase the replicas, decrease the replicas set. You can create the deployment. Let me see if we can have the service as well. So so when I look at the service, okay, let's first put this 80 and then configure this one. I'm not sure, since it is a Minikube, I'm not sure if the service will exactly work or not, because I tested this one in the actual multi-node cluster. Now, here I have the service, and what I'm doing over here is that, sorry, what is that? What I'm doing over here is that it's kind of the service, and the type is node port. And also I have given here the selector is app is Nginx. So if you look at the app Nginx in the deployment, also you will see app Nginx, and in the pod also you will see app Nginx. Is it there? Sorry, pod is not required because in the deployment itself we have given app is Nginx. So let's deploy or create the service kubectl apply. Let's f what's this host service YML. Okay, so your service is also created. Let us see, get svc. In short, you can say svc. And here you can see service nginx node port it is created. So I'm not sure if we can access this one, but let's try. Sorry. Welcome to nginx. So this is where you can see. Let's try to um, remove the service just to make sure that we are actually receiving this. We are getting this Nginx server. So what you can do to remove any resource, kubectl delete /f and then your host service YML. So now service is deleted. Now let's try to access this one again. Okay. Okay, so that means this Nginx is not from here. Sometimes if everything is in the Docker environment, sometimes it's very difficult to configure the network because again, everything is happening inside the containers. So let me try. Okay. Sorry. Local host and then 89. Okay. I guess 3.1. I believe that's not work. Okay, this will not work as usual. Okay, it's just how the container, sorry, Docker is configured. Based on that, it's not able to access this one. But what will happen if we put directly the IP address? Probably that will work. We should be giving the IP. Okay, it will not work because we are outside the network, and this service is the node port service. So outside the network, probably this will not allow any request to be served. Any request coming from outside the network. But this is how like a overall idea that how you create the pod, how you deploy the pod with the replica sets, and then how you uh, create the service. And if it is node pod, then it is node pod. If it is a load balancer, then you'll mention over here the load balancer, right? So obviously during that time you need to make sure that the port numbers are configured properly. Uh, Usually in the minikube, it's always very difficult because in the minikube, you'll have the Kubernetes network itself. Again, below that, you'll have the Docker network. Again, below that, you'll have your host network. So there are multiple layers of networks implementations out there. So that's why sometimes it's not so easy uh, to deploy or to access the service uh, when you are using Minikube. But if you have multiple virtual machines, um, maybe using Oracle VirtualBox, then you can go for, instead of Minikube, you can go for K3S, which is again a very easy one and which is very much more efficient one. So I would encourage you to, instead of using Minikube, I would encourage you to go for K3S, have your own virtual box, have your own different virtual machines, and have different and install K3S on top of that, at least like 3 virtual machines, and install K3S on top of them, and you will be able to perform this task. So I will share all these things. For example, like I will share all these resource files and the manuals over here. In the manual, it's also mentioned that how to install and how to start it. But of course, this is for the Minikube. But after that, working with pods and everything, obviously the commands will be same. So there is no difference. Working with the deployment, for example, working with working with the services. So all those things already mentioned. The manual is mentioned over here. I'll share this one along with the slides. So this is all about your orchestration, container orchestration using Kubernetes. So if you have any question, you may simply ask, or you can also send the message. Some of the things that if you want to explore, that how you keep the volumes persistent. What is persistent volume? What is persistent volume claim? What is scheduling? What is configuration? I mean, these are something like a little bit of advanced, and 90 minutes sometimes is not enough to cover everything along with the demonstration. So that's all about the session on Kubernetes or the container orchestration. So if you have any question, you can simply ask. Okay. Yeah, if you have
no question is there, I think only attendance something. Everyone.
Okay.
Okay, then tomorrow what we are going to cover?
Tomorrow we'll cover the Ansible. So that is slightly different. That will allow you to model the application in an agentless base. So we'll discuss that one tomorrow.
So if you have any questions, you can write in the group, or you can directly.
This is usually like very complex things. And if someone is not familiar with Docker, then coming directly to the Kubernetes is really too complex one. And that's usually the disadvantage of Kubernetes.
And all of you just try to implement at any point of time, any problem. After the summer school also, you can contact to Chinmay sir directly. Okay. And definitely we are planning for a internship, free internship. If anyone interested for the work, any small projects they want to do, we can conduct 1 or 2 sessions, Sunday meeting like that. For those students, those who are interested for the particular problem statement, we'll do. Okay, then. Thank you, Chinmay sir.
Yeah.
Okay. Thank you very much.
Yeah. Thank you. Bye-bye.